Okay. So this is my module 3. So our data, we're going to be looking at a dichotomous outcome, which is did students graduate from college? We're going to have one continuous predictor and then one categorical predictor with 4 levels. So that's I'm looking at parents' educational level. So no high school, college degree, or advanced degree beyond college. So for our data, we first did a dummy coding. That's necessary because regression can't handle nominal variables with more than 2 levels. It also allows the test to mean differences between groups, and so it's a very useful tool for this instance. The base that we're using is no high school diploma, which is decided based on relevant theory, and then each subsequent group is going to be compared to the base. We see that there's a creation of 3 variables, and that is because of k minus 1. So we had 4 levels, and then that ends up creating 3 new variables. So after running a linear regression model with our data, we see that there is significance for our result. And then when holding other variables on a constant, students with parents with education do better than those with no high school education or not finished high school education. But we do have a dichotomous dependent variable, so we kind of just see if this is really our best fit. But just based on this alone, you can see that even with our R square, we are accounting for a certain or a good amount of variance. However, when you start looking at our diagnostics, it's not very good. So we can see that there's no normal distribution. And on our left, we see an S shape, which suggests bimodality. And then this is problematic because even if some consideration was put into this, based on theory of what was being asked, linear regression is not really the best option. And you can kind of also see the lack of normal distribution in the histogram to the right as well. So this is problematic also because Freeman points out that without the right kind of theory or reasonable empirical validation, the conclusions drawn from models are going to be pretty questionable. So we kind of need to think what else is a better option. So we can consider the general linear model compared to the generalized linear model. So the GLM, your data, the relationship needs to be linear, but so does it with the GLIM. However, the GLM has more assumptions that need to be met, including normal distribution and homoscedasticity. And with GLIM, you don't necessarily need normality. You're able to still use it. So as Press and Wilson point out, logistic regression is relatively robust because of the less assumptions, and you can have multivariate variables that can be normally distributed or not, or dichotomous, or a mix of both. So a good option is logistic regression because it's best for our data based on having a binary dependent variable. And then we can use it considering we have multiple explanatory variables used for the classifications for our binary variables. So here you see that there is statistical significance. Previously with the GLM linear model, you use the B coefficients, and they represented the change in outcome variable that would be caused by the unit change in specified variable. Here they are log odds actually, so what we can kind of see has a lot of value. We do see the significance here, but this column here are our odds ratio. So the odds ratio indicates that when holding all other variables constant, a person whose parent has graduated high school is 2.4 times more likely to graduate than a person whose parent did not graduate high school. That is 6.9 more likely, or 6.97 more likely for those who did get a college degree, and then you see here 4.8 times likelier if their parents has a advanced degree. And as far as conscientiousness, we can see that that is also a significant and more likely for those who have higher conscientiousness, that they're more likely to graduate. So here you actually lose some of our statistical significance when we try to have an interaction term between conscientiousness and parent education. But overall, the logistic regression is a way better fit for our model, for our data. So this is primarily based on the fact that we have non-normally distributed dependent variables, and it's important to consider theory and data when determining what models to use for your actual data.